Hello, my name is Ian Haynes and I'm PI of the Rome Transform project. In this short presentation, I'd like to explain the methods and indeed the vision of the project as followed by my colleagues and I. It might be useful to start by noting the location and scale of our research area in southeast Rome. We're looking at this area from the 1st to the 8th centuries CE. Starting therefore in what would historical terms be the Principate of Augustus and concluding in the Pontificate of Pope Leo III. And during this time, we can see this area going from a relatively marginal space on the boundaries of the city of Rome beyond the Pomerium to becoming very much a central space. This area becomes the heart of Western Christendom for a millennium. In the presentation, I'm going to focus on how we capture data and how we integrate that data. We are very much conscious of the fact that we are taking a series of steps through the data in order to ensure transparency, and that each part of our work is both transparent but adaptable by others in the future. So we seek to ask some big questions of transformation, but in this I'm talking about those early stepping stones of how we capture the data to an appropriate standard and actually pull it all together. The first thing is managing space. We have a large research area of some 68 hectares, so we divide this into 9 working areas. If you look at our research area from the air, you can see that there is a lot of modern building, but you can also see there are substantial areas of green space. And at the bottom of this image, you can see the Lateran complex, which is at the heart of our early exploration of this project area. And at the top, towards the right, you can see the area of Santa Croce, the Basilica of the Holy Cross. Data capture. One of the points I would note is that there are many different facets to our data capture work, but crucial is that everything needs to be re-recorded and observed by eye, whether we've got exposed archaeology high above ground or deep below it. All needs to be recorded once again to the same system, whether the work and area has been published or whether it is unpublished. There are many areas of exposed archaeology in this part of Rome. Though the approach is overwhelmingly non-intrusive, we do use an array of mildly intrusive methods in the form of mortar analysis. But looking at fabric is also a vital part of what we do. All that we do in terms of structural analysis is backed up by the creation of large digital models of all of the structures that we have, and these have to be metrically correct. So our main instrument for doing this is the terrestrial laser scanner, and in this case you can see the Faro focus within the Lateran Basilica. But we do also, particularly for high structures, use structure from motion photogrammetry. And that allows us to develop models that can be meshed on occasion with TLS, terrestrial laser scan data, to create our 3D models. Now we keep coming back to and using and recutting and remeasuring through these digital models, so they ensure a good ongoing dialogue as we seek to understand the data better. So that's one part, structural analysis. The next part that's very important to us is the geophysical survey work, and we use a variety of different radar systems and some very fine teams from multiple different partners in order to basically have the largest geophysical survey ever undertaken in Rome. And a number of different forms of software are deployed to facilitate the analysis of those anomalies. Here you can see an example of a GPR survey on some of the busy roads that run through our area. We use alongside ground penetrating radar, ERT, or electrical resistance tomography, and that has certain different qualities, often allowing us a greater depth penetration in the areas we're working. Brought together, the geophysical coverage is pretty extensive, as you see here. Now, when I say brought together, it's important to note that we also have an environmental survey, which is designed to run alongside these other surveys. So it captures data of vital importance to environmental reconstruction in its own right, but it also helps to illuminate evidence from structural archaeology and indeed geophysics. How do we seek to integrate these forms of data? Well, one point that is, of course, of considerable importance to us is that we have a large body of legacy material and a significant amount of archive material to take into account as well. So that also has to be part of the mix of our research. Let me now show some of the systems of data integration that we use. One of the first that we use to work through interpretation of material from different sources is what's variously called by us three-tier visualization, but sometimes also referred to as full data models. Here's an example taken from the archaeological area of Santa Croce to the east of our research area. Here you can see a single time slice from ground penetrating radar. And if you look on the left, you can see elements of a structure emerging just adjacent to the line of the Aurelian Wall. The Aurelian Wall here and that structure here. Now, this is not a particularly beautiful model, but it's a good model to think with. What we've done is we have geolocated correctly the 3D anomalies shown up by the ground penetrating radar and placed them in correct spatial location to laser scans of elements of the Aurelian Wall and the porticus that ran through this landscape. That helps with our interpretation of the relationship of these structures, both thematically and, of course, chronologically. But clearly, there are limitations to what can be done with archaeological geophysics in terms of getting tight dates on structures. So we continually look also at other sources of information for that. When we bring our data together, what we're moving towards is what we call provocation. Now, this is a term that's often understood by team members as being at the heart of what we do. We look at visualizations as an essential way. We think visually as we bring data together, but we also emphasize that however compelling or attractive a visualization might be, that it is at the end of the day an argument, and an argument that we want to use to solicit responses from other colleagues, other specialists, both within the team and beyond, and that it is part of an iterative process whereby we refine our understanding of buildings, complexes, and landscapes. To give an example of this, I note work that we've undertaken immediately to the north of the Lateran Basilica in the Ospedale di San Giovanni in Laterano. And there are a series of excavations undertaken originally by Scrinari, which have been reappraised by the project. Working in and on both the Scrinari archive and also the archaeology as exposed today beneath the hospital has, amongst other things, illuminated our understanding of a late antique domus here. Now, from the information that we've been able to retrieve from that site, it's been possible to offer this visualization. But as I say, we think of visualizations as provocations. And so we note that this visualization, based on a multiplicity of important sources of information, has to have a compelling body of reference information so that colleagues can actually determine why it is that we argued for a certain interpretation. Here, what we're seeking to do is not simply to respect the excellent principles of the London and Seville charters, but to produce what is a resource for researchers. And our system, RT-SHEDOC, which is developed in conjunction with colleagues from Darmstadt, particularly Mark Rell up there, has allowed us to also offer justifications for different, equally plausible hypothetical visualizations of structures. So you can visit RT-SHEDOC online, and you will find a whole range of models produced by the team that we are using to advance our analysis of these elements. Buildings and landscape visualizations all really need to be situated, of course, within a wider understanding of the changing landscape. And in this case, some of the changes just in ground surface alone are very substantial indeed. So particularly with our colleagues within the team at Florence, we've had tremendous success developing RT3D. This is a system that brings together different forms of data in order to create new DSMs, digital surface models, or DTMs if you prefer, digital terrain models, of ancient ground surfaces. And it is important to note that in a number of cases between the 1st century and the present day, we have jumps of 8 meters plus in the ground surface. So when we're situating and understanding how transformation of landscape and transformation of buildings works, we have to be aware of this important 3 and indeed 4-dimensional aspect. So RT-SHEDOC allows us to take this data and to generate new DSMs and DTMs that can be incorporated into GIS. If I want to show you an example of how data integration might work, here's another example taken from the front of the Lateran Basilica. In this case, you can see our colleague on the right, Elena Pommer from the British School at Rome, undertaking ERT survey. Now that ERT survey is being conducted in the green area you see on the right here, the green triangles. And also on the hard surface immediately in front of the basilica itself. Now there are a couple of things that we've done here. One of them is that we have undertaken a borehole survey here, and you can see 2 points through this section, this ERT section, which show borehole data superimposed. And that anchoring of ERT sections and cross-referencing it subsequently also with GPR with the borehole data helps to strengthen our understanding of the subsurface conditions that affect anomalies, gives us a sense and an opportunity of sampling to some of the material that actually relates to those. So when we drive the boreholes through these areas, we're looking at a range of material, both for environmental reconstruction, for radiocarbon dating. Sometimes we will get indications of structural archaeology as well, but also, as in this case, we will sometimes see traces of voids marked by these light blue areas, which may reflect, in this case, Pozzolana quarries. Now, if we go back to this same area, one of the things we need to be able to understand is the physical relationship of the GPR and other geophysics data with regards to different phases of structural archaeology and landscape change. So let's have a look now immediately east of the front of the basilica. And with the help of some of the analytical work that we've been doing, we can actually locate a series of structures and reference them appropriately in terms of their depth in the modern landscape and beneath the ground surface today. Now, what we hope to do with all of this is to help advance together work on 3D GIS data, and we've benefited a great deal from collaboration with Archeocita and Forma Romai, and we look forward to actually supplying and recycling and reproducing information back into those systems as we advance through the project. So this brings me to the end of my brief discussion of our vision and method. We will be talking much more in separate videos about how transformation works and how some of our more detailed interpretive process works, but I hope this offers an introduction. And I would add that we have now available freely available online a volume from early in the project in which we outlined our methodology and presented that alongside leading practitioners at other sites around the world, and a volume summarizing the different methodologies being used by colleagues can be downloaded at the URL here. Final point, I come back to the fact that this is an ERC project, and we thank the European Research Council for funding for Rome Transformed under Horizon 2020. We also owe a debt to many different generous colleagues for their support in terms of access to material and sites. And most of all, I particularly owe a debt to the many members of the project team who've made this work possible. Thank you.